Hey guys, this is Amirash and I welcome you to your chemistry class. In this class, we'll be understanding the chapter Carbon and its compounds and the topic covalent bonding in carbon. So let's get started. So you all must be wondering that what are we exactly going to do in today's session? That is Carbon and its compounds 1, the first session. So let's see. So I welcome you to today's session and we are gonna rock this time. So what are the topics that we have, guys? Let's understand that. So basically we'll be focusing on bonding in carbon, that is the covalent bond. All right. So the topics that we have are introduction. What is exactly this covalent bonding? How can we relate it with ionic bonding? Yes, how can we relate and covalent bonding along with compounds? How do we form covalent compounds? Okay, we'll understand that also. So are you ready? In case you are, do not forget to hit the like button and share it among all your friends and subscribe to the channel. Without that, you wouldn't get the notifications and I want all of you to enjoy all the classes. Okay, so did you know, guys, that in plants 45% by weight, they are made up of carbon. So carbon is everywhere around us, even in our body, in all the organic substances. Okay, in all the organic substances, in our food, everywhere we find carbon. Okay, so let's have a look at this carbon, that what is so special in carbon and why are we studying about it. Number one point that you should remember, the study of carbon and its compounds comes under organic chemistry. So this is GK that you should know. But why carbon study is separate from the studies of other elements or the studies of the atoms and molecules? Let's understand that. We will be understanding it subsequently. So first of all, you should be familiar with the symbol of carbon, that is C. Capital C is the symbol of carbon that we have. Then the atomic number is 6 because it has 6 protons. 6 protons are present along with 6 electrons. Okay? So that is why atomic number is 6. Mass number is 12. It means 6 protons plus 6 neutrons, which makes it 12. Then physical state is solid. Okay, type of element, it's a non-metal. Remember that. Some people get confused if it's a metal or non-metal. So carbon is a non-metal. Okay, it's not a metal. Then what is the electronic configuration? That is 2, 4. Why? Because in the first shell, maximum electrons can be 2. 6 minus 2 are going to give you 4. So 4 in the second shell, 2 shells only. This is the K shell, this is the L shell. Okay. Then type of bonding is covalent bonding. Okay, that we'll be discussing in a few minutes. And allotropes, that is something which we'll be discussing in a few minutes again. They are graphite, diamond and Buckminster fullerene. So we'll be understanding about it. Okay, now first doubt that you must be having is, what is this valency? Just now we talked about the electronic configuration. What is the valency? See, valency is the combining power or combining capacity of the element, that how it combines with other atoms or elements by gaining, losing or sharing of electrons. Okay, gaining, losing or sharing of electrons. Okay? That is termed as the valency of that particular atom. If I talk about carbon, then carbon's valency will be 4 or no? Because 4 atoms are present in 4 electrons are present in its valence shell. Valence shell meaning the outermost shell. So how many electrons are present? 4. So valency becomes 4. So that is the combining capacity of element. What is the electronic configuration? Electronic configuration is how can you put electrons in different shells. So in the first shell, maximum of 2 electrons can be accumulated. So in the second shell, automatically 4 electrons are there of carbon since its atomic number is 6. Okay. Now the reactivity of elements is explained as their tendency to attain a completely filled outer shell, that is attain noble gas configuration. So every element wants that its outermost shell should have 8 electrons. Noble gases are the gases which have 8 electrons in the outermost shell, and this is known as octet. And there is an octet rule, which means that in the outermost shell of that particular element, 8 electrons should be there. Why? For existing, guys. Okay, for stability, so that they can be stable and they can live happily. Okay. Now let's take the case of carbon. कि क्या है carbon में? What is so special in carbon? See, number one point to be understood, guys, is that Carbon has four electrons. Now please focus over here to not get distracted. I'm teaching something very important. Carbon has 4 electrons in its outermost shell. Clear? And carbon will do something. Either it will gain or it will lose 4 electrons to attain a noble gas configuration. What would carbon want? See, if carbon has configuration 2 4 right now. So if it will gain 4 electrons plus 4, so its configuration will be 2 8. Stability. What if it loses 4 electrons? If it loses 4 electrons, then its configuration will become 2 or no? Stability. This is the duplet rule, which is another rule for hydrogen. Duplet rule, that in the outermost shell 2 electrons should be there, then the atom is going to be stable. Okay, so this is the condition. But then what is the problem? Let's understand that. See, 6 protons plus 6 neutrons form carbon, and neutrons are red over here, electrons are 6, because the number of protons and electrons are equal. Clear? Now, what if it were to gain or lose electrons? See, it could gain 4 electrons forming C4 anion. Anion meaning negatively charged. If it gained. But then the problem would occur that it would be difficult for the nucleus with 6 protons to hold on 10 electrons. That is 4 extra electrons. Guys, remember, for gaining, losing or sharing, a lot of energy is needed. And this much energy cannot be used up to gain 4 electrons. It will be very difficult for a chotu sa nucleus to handle 10 electrons, like 10 negative charges. Can you imagine? And just 6 protons. So this much capacity is not produced by the nucleus. Okay, so that is why this portion cancelled. It cannot gain electrons. Okay, so 4 electrons wala part cancelled. Now, what if it lost the 4 electrons forming C4 cation? Cation meaning positively charged ion. Ions are formed by gaining or losing their charge or valency. This forms ions. Okay, now what if it lost 4 electrons forming a C4 cation? Now again, so it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus holding on to just 2 electrons, which would make the nucleus even weaker. Why? Because it needs a lot of energy to break those forces of attraction and remove those electrons, those 4 electrons from the cell, from the nucleus. Sorry, so there will be just 6 protons and just 2 electrons left. What is this? So this wouldn't make it stable at all. So this plan also cancelled. So if carbon cannot lose, carbon cannot gain, then what to do? What to do then? What do you think? What would you do? Let me know in the chat box right away. What would you do? I want to hear. What would you do? Chalo, theek hai, now focus over here. I hope so. Now the screen is visible. Fine. Now focus over here. Carbon overcomes this problem by sharing its valence electrons with other atoms of carbon or with atoms of other elements. So what carbon does, it shares its electrons. Clear? This is the property which carbon has, because sharing is caring, right? You all agree on it, with atoms of other elements in this way. So in this way, carbon shares over here. 4 valency kind of a thing is there. I'll teach you how to do that. Now, how this sharing is done. The shared electrons belong to the outer shells of both the atoms and lead to both atoms attaining the noble gas configuration. So if carbon is going to give 4 electrons to any element, that element also has to give 4 electrons to carbon, so that both the elements will be able to complete their octet separately. Okay, this is the concept. So are you having fun? Isn't it easy till now? I hope so. So that is why carbon chooses the idea of sharing the electrons. Now we need to understand how this exactly happens. Now some compounds formed by sharing of valence electrons. Now let's say I am taking the example of hydrogen. Now you know hydrogen, its configuration is 1 proton, 1 electron. Okay? Only 1 electron is there with hydrogen. So what it can do, it can gain 1 electron, so that its configuration is going to be 2 to be satisfying the duplet rule. So what will it do? It will meet his friend hydrogen. Okay, it will meet his friend. His friend hydrogen also needs one more electron to complete the duplet rule. So they will say, hydrogen will say, hydrogen, yeah, please give me please share one electron with me. I'll also share one electron with you and we'll make a compound. So they said, okay, let's make. So how this happens now, try to understand. Suppose this is hydrogen, this is hydrogen. One electron here, one electron here. So what it will do, this hydrogen will get these two electrons. Okay, it is gonna get one electron of itself and one from that hydrogen, and this hydrogen will gain one electron from this. It will share one electron with this. So in this way, you're able to see that these two electrons are shared. So I hope that you got the clarity how hydrogen forms the bonds, that these two, this one pair of electron is shared between both the hydrogen atoms. Okay, now let's talk about the formation of chlorine molecule, how chlorine is formed. Let's try to understand that. So you know that chlorine's configuration, let me change the pen. Okay, so chlorine's configuration is 287. So basically it needs one electron to complete its octet. So what happens, that two chlorine atoms, they combine together. Yeah, and I forgot to tell you one thing, that because two hydrogen atoms combine to form a hydrogen molecule, so we call it H2. Okay, so it is H2 molecule. So over here Cl, you can make the electronic configuration easily over here. 7 are there, so you can write 1, 2, I'm making dots, 3, 4, 5, 6, 7. Similarly, 1, 2, 3, 4, 5, 6, 7. So what will it do? This chlorine will share one electron with it. This chlorine will share one electron with this chlorine. So you can make 1, 2, 3, 4, 5, 6, 7, 8. Octet completed. 1, 2, 3, 4, 5, 6, 7, 8. Octet completed, and this one pair is shared. So over here you're able to see one pair of electrons are shared. It means two electrons are shared. Such bond is known as single bond. Remember. Okay, single bond, as you're able to see in this picture. Clear? Similarly, oxygen molecule, same. And remember, we represent single bond by this, by a single dash, Cl, Cl. Similarly over here, hydrogen, hydrogen. So this is the way of representing the single bond. Clear? Now they both are stable and happy. They're like Majjani life kind of a situation. Yes. Similarly in oxygen, this shows double bond because two pair of electrons are shared. Let's say this is my first oxygen, this is my second oxygen. So I have 6 electrons in the outermost shell. 1, 2, 3, 4, 5, 6. Similarly over here, 1, 2, 3, 4, 5, 6. So this will share its 2 electrons. This will share its 2 electrons. Done. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 2 pairs. It means 4 electrons are shared over here. So this is known as double bond. And we represent double bond in this way. See, oxygen, 2 bonds, 2 dash, oxygen. Clear? Now you can take the example of nitrogen molecule. How this happens in nitrogen? In nitrogen, 3 pairs of electrons are shared. So it is known as triple bond. And we represent it by N, 1, 2, 3, N. Let's understand once how in nitrogen this is formed. So nitrogen, what is the configuration? That is 2, 8, and tell me what is it? Come on. Yes. Wait a second, not 2H. Just a second, sorry. That is 2, 5. Clear? 2, 5 is the configuration of nitrogen. So 5 electrons are there. See, you can see over here 1, 2, 3, 4, 5. These are the shared pairs, nah? And 3 electrons are shared over here that you can see. Clear? So that's not a difficult thing. You all can do that. Chalo. Okay, understood everyone? So triple bond happens over here. See, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5, 5, and these 3 are shared. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 over here, 8 over here. Stability. What else do they need? Yes, stability only. So in this way we can see. And the extra electrons will be written as dots. And the dash indicates the shared pairs. Remember that. Now, can you draw the electron dot structure for ammonia molecule? Can you? So what is the formula? That is NH3. Exactly, we can draw, can't we? See, there will be three hydrogen molecule, three hydrogen atoms and one nitrogen. So you can draw nitrogen over here, one hydrogen here, one hydrogen here, one hydrogen here. Can't you draw? Definitely, this will have only one electron, one electron, one electron. Nitrogen 5, 1, 2, 3, 4, 5. Done. Now let's talk about this hydrogen. This hydrogen needs octet, duplet, so this will take one hydrogen wala electron. Similarly, this hydrogen will take one electron from nitrogen, and this hydrogen will also take one electron from nitrogen. So hydrogen का duplet तो complete हो गया है, as we are able to see. Now moving on to nitrogen's octet. Now, since three hydrogen atoms have shared one electron with nitrogen, so their electrons will be added to nitrogen's configuration. So these three electrons plus 5 electrons of nitrogen would help nitrogen to complete its octet. Okay. So in this way you can see, clear? You can see the structure, ammonia molecule structure. Similarly with it, these are the shared pairs as you're able to see. Water molecule, how will you draw H2O structure? In the same way. Now this is your homework. H2O structure अपनी कॉपी में बनाओगे सब लोग, ठीक है, सब बना सकते हो. Moving on to methane. Now methane's formula is CH4. Now till here we were just understanding the basic structure of covalent bonding, which is between two non-metals. This can be asked in your exam. Covalent bonding takes place between two non-metals. Remember that. Now we are moving on to methane. How carbon forms. So carbon attains stability by octet configuration. Hydrogen attains stability by duplet configuration. I have already told you. Chalo. Now this is methane structure. We'll be understanding about that. Now compounds formed by sharing of electrons. So you can see that methane, hydrogen, chlorine, oxygen. First, let me explain you over here. Okay, I'll explain over here. Now focus over here. How did we form methane? This is carbon. Okay, how many? What is the valency for? 1, 2, 3, 4. Clear? Now hydrogen. What's the valency? 1. This hydrogen valency 1. This hydrogen valency 1. And this hydrogen valency 1, because hydrogen can just share one electron. So 4 hydrogen atoms are going to combine with carbon atom. They are going to share the electrons. So carbon, this hydrogen ka duplet completed. Similarly, this hydrogen ka duplet completed. This hydrogen ka duplet completed, and this hydrogen ka duplet completed. Now carbon needs octet, so it will take the electrons from hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8. बन गया structure of methane gas, that is CH4. CH4 is the name of, this is the formula for methane gas. So I hope that is absolutely clear. Now what is a covalent bond? Such bonds which are formed by the sharing of an electron pair between two atoms. Co. What is co? Co means sharing. Okay, bacha party? Sharing. Valent means valency. So sharing of valency meaning sharing of valence electrons. Electrons in the outermost shell. When we share them, if carbon is giving one electron to hydrogen, hydrogen also has to give one electron. This is sharing. Equal number of electrons are shared between two atoms. Like in this, in CH4 and methane's config, this structure you can see, carbon is sharing its 4 electrons with 4 hydrogen atoms, and these 4 hydrogen atoms are sharing each of their electrons with carbon, okay, which completes their octet and duplet respectively. Samajh mein aaya? In case you understood, hit the like button. Okay, bonding in carbon. Now how carbon forms bonds? By sharing of electrons. Now bond formed by sharing of electrons is known as covalent bond. Now one carbon atom forms 4 bonds. What is that? Single bond, double bond and triple bond. And I have told you how to indicate single bond में C dash C, double bond C, 2 dash, then C, triple bond C dash dash C. And in the next session, we'll be understanding about the versatile nature of carbon. That why is it so special? Now, compounds formed by sharing of electrons, you can just have a look at it. Then, so you can have a look at some compounds once more. Then, like here we have hydrogen. You're able to see here we have hydrogen, then we have fluorine, then we have carbon dioxide in the same way. Now you have to make them, otherwise you wouldn't understand. Now carbon tetrafluoride and all that. Now I have explained you. Now you can do that. Now some properties of covalent compounds. Covalently bonded molecules are seen to have strong bonds within the molecule, but intermolecular forces are small. So forces of attraction are small. They have strong bonds, but forces of attraction are small. Okay. This gives rise to the low melting and boiling points of these compounds, that they can easily be melted or boiled. Clear? Because of this only forces of attraction. The electrons are shared between atoms and no charged particles are formed. Such covalent compounds are generally poor conductor. So there are no charged particles, no ions are formed. So they are poor conductors because just the electrons are shared. Like you share tiffin with your friends, right? You will say, "तू मुझे मैगी दे दे, मैं तुझे पास्ता दे देता हूँ." In the similar way, carbon and hydrogen or any of the two elements they share. And now one homework question, that compare the properties of ionic and covalent compounds, that you have to let me know in the comments. Okay, please let me know in the comments. I'll feel good if I'll receive more and more comments. And to like, share and subscribe. I'll catch you up in the next session. Till that time, let's say bye bye. Bye bye.